measures of center are things that you've seen before. This is the mean, the median, and the mode, okay? You've probably been talking about these since 5th or 6th grade. They're quite common in late elementary and middle school math curriculums. We're just going to go into a little bit in depth, but not too much because we want to get through this pretty quick so we don't bore you with the mean, median, and the mode. Okay, so we're going to start out. And by the way, remember, these are called measures of central tendency, the sort of the center pivot point of a data set. So we're going to start with the mode, and the mode is that number which is the most frequent, okay, or most often occurs. And so if you think about maybe if we were to draw like a little bit of a histogram here and think you had, bars that kind of like were like this. Remember, these bars represent the frequency. So if this one had 6 and this one had 8, you would say that the mode is 8. That 8 is the number that appears the most often because its bar is the tallest. Okay, if you want to think about that way, the bar, the bin, the bucket, the class has the highest frequency. That's what you'd think. So that's the mode, okay? If you happen to have two numbers, so let's say this bar actually went up with the same frequencies, so you had an 8 and an 8, then you would say that there are two modes. There are sort of two values that have the most frequency, and that would be called bimodal. Whoops, over here, bimodal. Okay, so two modes would be bimodal. If you have more than two, then you just say there's not really a mode. Kind of like if you had 3 or more winners of a race, you'd kind of say, well, there's not really a clear-cut winner. So if you have a lot of values, categories with the same number of frequency, you would say there's no mode. So for example, if we had a bar graph that looked, something like this, and each one was, 8, 8, 8, 8, 8, you'd say no mode. The mode does not exist. There's not one number that has the most frequency. They're all sort of the equal frequency. And so we'd say no mode, okay? The second number, or the second measure of center, is the median. That's the number that if you line them sequentially from least to greatest, it's the number in the middle, okay? And then finally, the mean is what we think about when we say the average, okay? So you add them up and divide by how many there are, and that's what these formulas say. Add them all up and then divide by how many there are. Now, if you're looking for the mean in a population, which we will rarely do, then you use mu to represent the mean. Mu is the mean. And again, we won't use mu that often. Usually we'll use X because we are dealing with samples. And so when you're dealing with a sample, the mean is this character, and that's pronounced X bar. It's the letter X with a bar over the top, okay? And so you just add up all the values, you divide by how many there are, and that's how you get the mean. So let's take a look at an example. Let's say you work at a veterinary clinic and you have 5 cats and you measure the weight of these 5 cats. You add them up and divide them by 5 and you will find the mean of the 5 cats' weight, okay? The median, align them least to greatest, something like this, least to greatest. And the one in the middle is the median. That's the number in the middle, okay? And then finally, the mode is the number that appears the most often, and that happens to be 8.2 pounds, okay? So mean, median, and mode. We then bring in another cat, one at 6.3, and we take a look at how these numbers change. And we'll skip through that and jump to the third example where our 6th cat that we bring in is really quite large, okay? So Garfield has entered the chat. You have a cat that is at 22 pounds, which is much, much larger than the other 5 cats. How does this impact those 3 measures of central tendency? So if you look at the mean, you now have this very large number included in the mean, and that's going to skew your mean. It went up. Remember, the previous mean was about 8 pounds, 8.02, and now it's at 10 pounds, okay? The median, however, again, here is that new value that we put in. The median doesn't change. The value in the middle is still 8.2. And also, when we add in that new 6th cat, the mode does not change. So in summary, if you take a look at this, when you take a look at the first example that we did, 3.11, this was the mean, the median, and the mode, okay? No big deal there. But when you added the outlier, the very heavy 22-pound cat, you'll notice that the mean changed significantly. but the median and the mode really didn't change that much. And this has led some people to make the argument that maybe the median and the mode are better measurements of the center of a data set. The reason being is that the mean can be influenced, the average can be influenced by an outlier. So if you have an outlier in your data set, it can really skew the distribution of that data. It'll make that mean a little bit not quite in a good measure of center, right? And so here visually is what we're talking about. So in the middle, you have the symmetric distribution. So this is a distribution where the mean, the median, and the mode all kind of line up. You don't have any outliers in this data set, okay? But if you had a situation like we have on the left here, and in this distribution, if I could draw a line that kind of extended, imagine that there's an outlier way over here, right? Like a really large value that is to the left. What that outlier will do is it will pull the mean and the median to the left. The median a little bit, not too much, but the mean will be skewed significantly to the left. Okay, think of this outlier out here as like a black hole, right? And it's got a gravitational field, and that gravitational field is going to grab onto the mean and tug it to the left. And that's why we call this left skewed, because you got a black hole to the left and it's skewing all of your data points. Okay, now we can still say if you put a ball on this, it'll roll to the left, it's going to roll to the black hole. But when you have a graph that is skewed left, chances are you have an outlier off to the left someplace, okay? The same thing's true for the right. So if we were to draw a line on the right here and place an outlier, our black hole right here, this 22-pound cat way over here to the right, that is going to skew the mean to the right. And again, because the mean is what is skewed most by outliers, some people will argue that maybe we shouldn't be using the mean to represent the average of data sets. If you have a bunch of students that scored, let's say, a 65 on exam, let's say the vast majority of students scored a 65 on the exam, but one student got a 100, that one student is going to skew the class average, right? They're going to sort of break the curve a little bit. Maybe you've heard that term, where someone scores really well on the exam, skews the average. Okay, that would be probably a right skewed situation. So this is a nice visual way to understand what's happening in this table and how susceptible measures of center are to outliers. Okay, the last thing we're going to look at are weighted averages, and you guys have seen weighted averages. This class has a weighted average, and the example that we give here is, let's say that you happen to be in a biology class, and here are how your final grade is weighted. So 15% is based on your lab score, your first exam, second exam, final exam. So you tally up your points for your labs, and you discover that you have 95 out of 100 points for your lab. So you're going to take that 95 and you are going to multiply it by the weight of that lab, 15%. Now, we don't multiply by 15, we convert it to a decimal, 0.15. Okay, and so that becomes the weighted component of your lab score. Then you do the same thing for your first exam. So your first exam, you got an 83 on it. So you take that 83 and then you multiply that by the weighted component for the first exam, which as a decimal is 0.25. You do this for the other components, and that will give you your weighted average. So your grade point average is a weighted average. This class that you're taking right now is a 3-credit class. That means we meet for about 3 hours each week, okay? You could also be taking a chemistry class that maybe is a 5-credit class, 5 credit classes, okay? So an A in your chemistry class at 5 credits has more influence on your GPA than an A in your stats class. Okay, so if you had to focus on making sure that what classes you got good grades in, make sure you get good grades in your classes that have the most credit hours, because they most heavily influence your GPA. Not saying you should ignore your stats class and study more for other classes than stats. We still want stats to be important, but that's the way the math works out.